All right, welcome back everyone for another deep dive. Today we're going to be looking at how things move and work, like the mechanics of it all.
Yeah, the stuff we never think about, like what makes a toy car go or how a bike works.
Exactly. We've got some excerpts here from a document that's all about electrical systems and DIY projects. Pretty interesting stuff. Should give us a good idea of the basic principles behind all this movement.
Definitely. It's all connected in a way.
Yeah, speaking of connections, let's start with circuits. I mean, we hear that word all the time. But what's really going on in there?
Well, the document talks about series circuits.
Series circuits, right?
And basically, it's like imagine electricity flowing in a single path, a straight line.
Like a one-way street.
Exactly. And that flow of electricity is called current. Now, the thing with a series circuit is if there's any break in that path, the current stops. Everything stops. It's like a roadblock.
Ah, that makes sense. I always wondered why those old Christmas lights were such a pain. One bulb would go out and the whole string would go dark.
Yeah, that's a classic example of a series circuit in action. One break and the whole thing shuts down. And I'm guessing the document doesn't talk about other types of circuits, does it?
No, not really.
Well, just for context, there are other types, like parallel circuits. Think of those like a city with multiple routes. You can still get around even if one road is blocked because the electricity has different paths to flow through.
So they're more reliable, huh?
Oh yeah, way more reliable. Parallel circuits are what we use for most things these days, the electrical systems in our houses and all that.
Makes sense. That brings up another question, though. I mean, we're talking about flow electricity, but what else is going on in a circuit? What's actually making things happen?
That's where circuit components come into play. These are the individual parts of a circuit, each with its own special job. It's kind of like, I don't know, an orchestra or something. You've got all these different instruments playing together, each with its own sound, but together they create the music.
Yeah.
I get it. So in a circuit, you've got things like resistors, capacitors, transistors, and even something as basic as a light bulb.
So a light bulb is a component.
Absolutely. Each component does something to control or change how the electricity flows. It's like a whole little world in there working together.
Wow, it really is. So we've got these circuits, they're powering things up, but how does that actually translate into movement? Like, how do things actually start moving?
That's where mechanics come in. The document mentions axles, which are key for anything that rotates, like wheels. Think about it. When you ride a bike, you push the pedals, right?
Right.
Well, those pedals are connected to a gear, and that gear turns the axle. The spinning axle then makes the wheels spin, and that's what propels you forward.
So the axle is kind of like the link between, in that case, my legs, the power source, and the actual movement.
Exactly. It's the bridge between the power and the motion.
Wow.
And the same principle applies to so many things. You see it in those tiny toy cars with the little motors and even, huge machines in factories.
Oh, yeah, for sure. And the axles themselves can be pretty different, can't they? Like a car axle is way more complex than one on a bike.
Oh, yeah, no doubt. Car axles have to handle way more weight and speed. It's a whole other level of engineering. But the basic idea is the same. Transfer power to create rotational motion.
That brings up a good point. There's a difference between, human-powered systems like a bike and something powered by an electric motor, like those toy cars we mentioned.
Right. With a bike, it's your muscles providing the energy that goes through the axle and makes the wheels turn. But an electric motor gets its energy from, well, electricity. And it turns that energy into rotational force to spin the axle, so the toy car can move on its own, no pushing required.
It all comes down to how that axle is being turned, huh? Whether it's us or a motor. Fascinating how that works.
Definitely. And the key takeaway here is whether we're talking about human power or electric power, understanding these basic principles of circuits, components, and axles really helps us understand how things work. And honestly, this knowledge isn't just for engineers or, people who build things. Anyone can use it. It can help you figure out how everyday things work, or even try some DIY projects around the house.
Like what?
Well, I don't know, say you wanted to build your own little toy car. You'd have to think about what kind of motor you'd need, the size of the axle, the circuit to power it all, and even things like, what kind of wheels would work best on different surfaces. It gets pretty detailed.
That's awesome. I never thought about it like that. It's like we take all this stuff for granted.
We really do. But once you start to peek under the hood, so to speak, it's amazing how much thought and design goes into everything around us.
This has been such a cool deep dive, I gotta say.
I agree. It's amazing what you discover when you start asking, how does that work?
So next time you see a toy car zooming around or you're riding your bike, take a second to appreciate the circuits and axles making it all happen. And hey, maybe you'll be inspired to try building something yourself.
Now, that would be fun.
Thanks for joining us on this deep dive, everyone. We'll see you next time.